Hello everyone, in this tutorial I will show you how to simulate mixture of ethanol and water inside this stir tank using by ANSYS Fluent. A stir tank is a kind of the equipment which is widely used in chemical industries for mixing the component. Following the simulation, we are gonna understand how the geometry is built and how boundary condition applied and how cell zone condition can affect on our simulation. So we will use transport model species, and we are gonna define impeller rotation speed, and also we are gonna run the simulation with the transient condition to observe mixing over the time inside the tank. Let's start with the simulation. And again, in the simulation's geometry includes a cylindrical tank, a rotating impeller with the shaft and inner rotating fluid zone. The impeller is placed inside the rotating zone to simulate motion using sliced material. Following the simulation, you will following the geometry, you will see. And the tank is stationary and an interface separated from the rotating region. There are no inlets or outlets. This is a batch mixing process. Let's start with the units and the millimeter, and I will sketch on XY plane. A new sketch. In sketching, I will select the line and I will sketch a line. Then I will use modify and split a region. Why I did this? We want to make sure that split this model into two sections and make sure that selected the right. And then I will use coincident, and it's a super useful, and when you need a body to match up exactly. Constraint and coincident, and select this to this, and then what we need to do using general length, and modify dimension general length. Here the length will be 60 millimeter, and the vertical position of the rubber blade, this is the vertical position of the one of the blades, not it's a 25, and angle, alternate angle, and angle will be 20, and everything is okay. The height from the point of the middle until x-axis, we should make sure with the right angle, and the angle was 20. So we should make sure that this length is equal to this length. So we will use the equal length. We will use equal length. Equal length, yes. Yes, the length now is equal. So then click on extrude, and press on apply, and operation will be at material, and depth will be 225, and yes. Inward thickness will be 3, and outward will be 3, and press on generate. This is our blade. And this is our first blade, and we will proceed the geometry. I will select the edges, this edge, and press Ctrl until this edge, and press and apply. Then the radius will be 37. Then press and generate like this. So what we need to do is to make a pattern, because we have one blade. We need to draw a pitched blade turbine, so it contains 4 blades. So we are gonna use pattern operation. So I will use this geometry part, then apply, and the pattern type will be circular, and the axis will be this axis. Apply, then 3, and generate. This is our blade. So we got our blades for our mixing tank. Next step is to create the cylinder, so which we use primitives and cylinder on XZ axis. Press and apply, and we will set our height and radius, and Z component will be 75 millimeter, and radius will be 18. Everything is okay, and press on generate. Yes. And what we need to do is to sketch a shaft for our impeller, and we should press on the surface, and press on plane, and then press generate. Then again we need to create another cylinder with the primitives and the cylinder, and from ZX axis press and apply, and pay attention. The operation will be add material, and the Z component will be 825, and the radius will be 13. Then press on apply. Yes, we can use this, generate. Yes, everything is okay, and I will change the Z component axis. Okay, everything is good. So now we should create actual body. So we need to use again the primitive cylinder on ZX axis, and now we should choose add frozen, and we will adjust the Z component. So the radius will be this, and the Z component will be this number, and the origin Z component will be minus 200. Press on generate. Maybe we can increase this number. Minus generate or minus. Yes, now it's okay. The next is using the Boolean function to subtract our inner body from the outer body. So we need to subtract our lathe from the tank. So create primitives, create Boolean operation, then subtract. Target body will be tank, and the tool body will be will be this. Press on apply, and pay attention about this option, preserve tool bodies. Yes, and click on generate, show all the hide bodies. Yes, and as you see here, we have a solid and a tank. They're separated. Well, what we need to do right now, we need to region around the impeller rotating. So we need to insert a slice cylinder. It's a stationary area on the outside and the middle. So why we need to use sliding mesh. So I will tell you in the following. So what we need to do is to draw slice material on a stationary area. So by using a create and primitives, then cylinder on the ZX axis, press on apply. So I will adjust these options to origin Z to Z component will be 125, and the radius will be this, and maybe we can use this. Okay, and the origin Z. Z components minus. Okay, then press on generate. Maybe this would be minus 60 or minus 50. Minus 50. And now everything is good. Well, and pay attention. The operation should be slice material. So it's important because it accurately simulates rotational motion of the impeller, capturing time-dependent flow patterns. This allows the realistic modeling of vortex formation and mixing behavior inside the tank. So press and generate. Everything is okay. Yes. What we need to do is to use a Boolean operation again. Boolean operation again to make a unit. So I will hide this, and again I will hide body, and making a unit all these bodies. Press on apply, then generate. Yes. Now you can see here we have both a shaft and impeller, and our tank, other side of the tank, and the inner side of the tank is rotational area. So I will change the name. It's like shaft tank, and inner part. Okay, and everything is okay, and I can use show all the height body. Yeah, our geometry is ready to meshing processes. Well, I will proceed with the meshing process. Well, here is the meshing environment, and we need to make a mesh on our geometry. So we will start with the mesh, and everything is okay, and I will start with the sizing. Yes, the element size will be 0.025. Okay, and the maximum size, also maximum size will be 0.095, and everything is good. Okay, and this will be 0.045. It's all right. And the curvature, these are okay, and this will be 5. Okay, and the other will be, yes, the maximum layers will be 4, and the transition ratio also will be 0.26. 0.26. It's okay, and we can generate our mesh, and we will wait to mesh generation. I will tell something. I want to tell you something important. This is a critical step for accurate results. We need to ensure good mesh quality, especially near the impeller and interface where we have high gradients occur. A key metric is weakness. Ideally, it should be below 0.85, and lower is the better. Another important value is the orthogonal quality. You will see them here, and we aim for values closer to 1 with the minimum above 0.2. And fine meshes use around the rotating zone to better resolve flow details and avoid convergence issue. So our mesh is quite important, as I said, because if we had bad meshes, it leads to convergence issue. So it's important for us to making appropriate mesh. And then we will proceed with name selection, because it's quite important section, because also the ANSYS try to understand with the name selection, especially for boundary conditions, for cell zones and other sections. So it's important for us to select our sections, what we want, and what are going to happen inside each section. So we will start with this part. Okay. I will select before, let me do suppress body and shaft suppress body, and I will select all the tank and create the name selection. I will select that tank, press on OK, then suppress, then I will suppress this body and unsuppress this. Well, this will be our shaft. Create name selection. Press on OK, and then press this body and suppress this body, and this body will be inner section. Create the name selection and inner part or inner domain, doesn't important, it's just name. Then press on OK. So before proceeding to setup section, you need to make sure you have made your mesh update. If you don't do this, you cannot proceed with the setup, and everything is okay. And here you can see the name selection. No, I made a mistake here. I should select as the inner part as the interface. Well, this will be suppress. Okay, suppress, and here will be interface. Okay, interface, yes. Everything is okay right now. All right. Also here. Yes, that's okay. We can create the name selection. Inner interface. Then press on OK. Okay. Well, as I said, I will update. Well, okay, let's start with the setup environment, and this is for our steer tank, and we are gonna start with the general setting first.
We are gonna set the solver type for pressure based as a default, and we are gonna select the transient, and then we are gonna activate it gravity effect. It's also effects on the gravity is reflect to elastic buoyancy effects in the liquid mixing. Then we will proceed with models. Energy is on, and viscous model. We choose K epsilon model to capture the swirling and the vortex effect. K epsilon model, and I choose this and enhance wall treatment. I think everything is alright, and we can proceed with the simulation. And also for species transport allows us to simulate the ethanol dispersion in the water without any chemical reaction. So this species transport will be on, and then before I've created, and I will press on the OK. Then with the material, start with the material. When you activated species transport, the mixture will be appeared here. Well, for the fluid, first let me to show you. Well, for the water, as a template exists inside the Fluent, you can easily choose water from the fluid part easily, and you can press on here and then press on the copy. You will see the water here. Then another component is ethanol. I've created before. This is the ethanol, and it doesn't exist directly inside the Fluent database. I've added the properties here, like the molecular weight, viscosity, thermal conductivity, which is important for energy, and doesn't important for this simulation, thermal conductivity or a specific hit. So then you will press on create. After then you will come here, water. I create the water ethanol, and then proceed with the mixture species and edit. And I've choose let me to show you. I will edit this. If I remove, okay, when you added ethanol, you will see directly here. If you add ethanol here, it will be shown as a species. So I will remove oxygen and proceed with this. Then start with cells on condition, which is the important part of the simulation, and we will start with the inner part, and pay attention to a material name. It should be water and ethanol mixture, and the frame motion should be activated, and the speed radian per second should be 13 or 20 or 10. It depends on your simulation. So then press and apply. So for shafts also, I will activate the frame motion, and the relative zone is a tank, and the material name should be mixture of the water and ethanol and the speed is the same, like 13 radian per second. So we assign frame motion to a rotating zone which moves the impeller. The tank remains stationary while the impeller drives the flow inside. The point is here, as you see, there is a mesh motion and the frame motion. If you activated the mesh motion here, you will see the option here. So what's the differences between the frame motion and the mesh motion? Well, we use frame motion to simulate rotation without physically moving the mesh. It's simpler and quite faster. But if we use mesh motion, the mesh actually rotates over the time, so capturing detail on a steady flow and like this. Well, mesh motion also is better for transient problems like steer tanks with the strong vortex formation. So in this case, we go with the sliding mesh to model the realistic mixing behavior. So I'm not going to work in with the mesh motion, just with the frame motion. Then click on apply. Well, then for the tank, we haven't any anything inside the tank, but I just want to add a mass fraction of water inside the tank. It's kind of the fixed value. And then the boundary condition, internal and the wall. There is a wall of the impeller and the wall of the tank. The wall of the tank condition is no slip condition, and we are gonna adjust the options for wall impeller. So it's always rotating. It should be as a moving wall. Well, as a transitional or rotational, I will choose the rotational and 13. Then press on apply. Then the wall tank will be no slip condition. It's a stationary wall. So everything is okay, and we are not gonna adjust anything. So we can start, I think. Yes, it's good. And it's the methods. What kind of methods do we want to solve our solve the equations? I will choose quick, and for pressure I will choose the presto. It's quite precise, and for turbulent also quick. Another things is to do. We need to start with the initialization. We start the solution with the zero velocity x, y, z, and use a patching to define water in the initial location. And this step sets the starting condition for the transient simulation. So as a before, I will add like we have 0.5 amount of mass fraction of the water. Then try to start to initialize. Okay, so patch, and the amount of water with the mass fraction is here, and I choose the location of the patching. Well, then we can start with the calculation. I'll start with this time step, and the maximum iteration is 1 and 600. Everything is alright, so we need to just start the calculation. It is time to analyze the result. First, let's check the residuals to confirm convergence. As you see, the convergence is almost good, and then we will go to contours and plot the mass fraction of the ethanol over the time to see the mixing progresses visually. Next, I will open the monitors where we track the ethanol concentration at the different points in the tank. From those plots, we can identify when the local value is stabilized near the average. That's our mixing time. Finally, I will show a few velocity vectors and streamlines to understand how the Impeller draw the follow. So, if we want to get the concentration of the ethanol at the different point, what we need to do, first we need to create a surface, point or plane. If you create a point, you will give your coordinates or different coordinates you need to give to the system, and also for plane, also for which side of the geometry do you want to apply your plane, for YZ or for XY plane. It depends on you. I'm not gonna create this because it takes more time. Then after creating this plane, you can easily get your mass concentration of ethanol. So to accurately determine the mixing time, we not only monitor local ethanol mass fractions, but also calculate the average mass fraction over the whole tank. We can do this using the volume integrals. You just need to go to results and reports, and you can take a volume integral and like species, and we want to mass fraction of the ethanol in each part, then compute. You can see here, this is the inner part. There is a mass fraction, and this is the shaft, and this is the tank. This the net amount of ethanol. So then what we need to do is to understand the path line also. Or also first let me to show you the turbulence inside the steer tank yes, maybe we can use this. You can easily see it. The turbulence effect has a more effect here. Also, the impellers and inner part. Well, let me to show you the velocity streamlines. Also as the line and the velocity magnitude display. We will see the streamlines have to recirculate inside the steer tank. Yes. We try to animate this streamlines, and you can. Now let's discuss about the velocity streamlines, which are the crucial for the understanding the flow behavior inside the tank. Streamlines show the direction and the strength of the fluid flow in the steer tank. They help to reveal how the impeller circulates the liquid. Ideally, we should see a strong downward flow. Means the impeller and the circulating loops that move fluid from top to bottom. This pattern indicates a good mixing, but if the streamlines show stagnant or recirculating zones near the corners, that means a poor mixing there. Well, we can also adjust the plane location or create animations over the time to see how the mixing develops and whether the flow reaches all parts of the tank. So it's the follow pattern as the streamlines, as you see. Well, this is the final part of the simulation. Let's see you with another videos and with another tutorials.